Okay, so continuing from the last lecture, we recap that what we observed for water waves, the fact that the intensity I12 was not equals to I1 plus I2, and we got an interference and a fringe pattern, and we were able to exactly quantify that fringe pattern for water waves in terms of the interference of waves. We defined two waves having amplitude h1 and h2 and a phase difference between them. H2 was H2 amplitude plus some path length, and we added the two waves, and we were able to get an interference term. Now, what we observed for electrons was a similar situation. When the two slits were open, we had the so-called interference pattern, and P12 was not given equals to P1 plus P2. And but however, if you notice that the interference pattern we got for electrons was similar to the interference pattern we got for the water waves. So we were able to directly import the mathematics, and the mathematics was given in terms of the Feynman rules, which were assigning a probability amplitude and basically, if we can argue that there is no way to determine which of the paths the electron took towards the screen, we add up the probability amplitude for indistinguishable paths. So we generalize this. If I am at I need to go from A to B, and I have several paths to take. And these multiple paths are indistinguishable. That means there is no information in the universe whatsoever to distinguish one path from the other. Well, then I add the probability amplitudes, which are complex numbers associated with each path, and the probability is given by adding up. So keep in mind, we still don't know what's going on. I mean, deep down, maybe the electron breaks up. I have a double slit experiment. Maybe the electron breaks up into two parts, does something, lands up on C, or does something. So this is the best way to make sense and get predictions for any sort of an experiment. And that sort of is what essentially is the hallmark of quantum mechanics, where as long as your processes are indistinguishable, then I'll add up probability amplitudes. And remember, we got to this conclusion by arguing that since P12 is not equals to P1 plus P2, then I cannot have the total probability from going from the electron gun to one of the slits towards any point C So my total probability is not going to be equal to this, and this implied that the value at AI does not have a definite value. So in some sense, the electron does not have a definite path. We do not know which slit the electron is taking towards this journey towards C. So that's essentially the idea, and then we argued that okay, we won't add the probability amplitudes. We observed that mathematically the pattern of water waves interference is very similar to what we observe for electrons, and we added the probability amplitudes just the way we were adding the waves in water waves. We added the probability amplitudes in quantum mechanics to get the prediction of the interference pattern for electrons. So this sounds a bit weird. How is it that the electron that starts from here, I'll just draw the double slit again. I have the electron gun. Electron that starts from here mysteriously doesn't have a definite value which of the two slits it's going to take, and it lands upon C. This is certainly very baffling. What if we try to watch the electron? So what I do is that I have a beam of light, and immediately as soon as the electron is going to pass through either of the slits, there's going to be a flash. My light photons are going to hit the electron and there's going to be a flash of light. This is a light source. So what is going to happen is that, let's say I have a very bright light source and I am observing which of the two slits the electron is taking, either this one or this one. I'll get a flash of light. So now electrons are watched. So in this scenario, what are my observations? Well, I observe is that there is a flash of light. Either at hole 1 or hole 2, but never simultaneously. So I watch an electron passing through either of the two slits, and when I try to watch it, either I get a flash of light near hole 1 or I get a flash of light near hole 2, but never simultaneously. So let's say my proposition now is electron is observed to pass through either hole 1 or hole 2. Well, I'm using the word hole and slit interchangeably. Slit 2. When I do the experiment, this is indeed correct. So my proposition, let me call it proposition B. Proposition B seems to be true experimentally. That's indeed, when I do experiments, that's what happens. So now where we are? Well, Initially, when we were not observing the electrons, we came to the conclusion that we have an interference pattern, and hence I should conclude that the electron doesn't have a definite value of AI. That means I do not know, not only I do not know which slit the electron passed through, that value does not even exist. Because if that value exists, I would had no reason but to add up the probabilities instead of getting the interference pattern. But when I try to watch the electrons, lo and behold, I am able to watch the electrons. Either it's passing through. So when I watch the electrons, there is a light source. Either A1 is valid or A2 is valid. This implies A1 and A2 have a definite value for this particular experiment. So what happens? What do I see on the screen? So on the screen, I have this electron gun. And there's a flash of light. I mean, there's a light source. So an electron passes through this. Let's say I launch the electron. There's a flash of light. It deposited itself on the screen. This is electron number 1. Let's say 2 for the electron number 2 for my experiment. I see a flash of light here, and it deposited over here. So click, 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 click. This is what is going to happen, and they are going to deposit on the screen.